Okay, so here we're going to do some angles on parallel lines, angles in polygons type questions, and go through them step by step. So first one is this one here, and the first thing to do when you get these sort of questions is to have a think about what shapes you've got there. It does always usually tell you as well. It tells you here that the ABC is a straight line. So that's indicating we can use an angle rules on a straight line. We've also got the fact that BCD is a triangle. Now, sometimes it's not always so clear to see the shapes as two separate shapes or three separate shapes even. You just see the bigger picture and you see that one shape you start with. So just take a moment to think, what have I actually got here? So the first, the yellow one here, saying that it's angles, the BCD is a straight line. Is a triangle, sorry, means we can use the rule that angles in a triangle sum to 180 degrees or add up to 180 degrees. And straight away, that gives you a reason, one of the reasons for your answers you're going to give later on. So if you do this bit first, then the calculations, you can actually have the information here to hand, and then you actually have got some points for reasons. Now the green one here, angles on it is a straight line, so angles on a straight line. Now you do need to actually put the word straight line. Otherwise you won't get the mark. Angles on a straight line, they're very fussy about the specific language you use. On a straight line, add up to or sum, whichever word you want to use, 180 degrees. I'm just going to change that first bit because it's annoying me, sorry. My pen went a bit weird. Okay, so. Okay, angles on a straight line, add up to 180 degrees. And the last one, the fact that it's a quadrilateral, so A, B, D, E is a quadrilateral. So angles in a quadrilateral equal, or add up to, rather should say, angles in a quad. I'm going to cheat here because the word's there. In a quad, add up to 360. So there's three facts already written down, and those could then be used as your reasons for your answer. Okay. So let's do some actual calculations then. So using these facts, now we usually start with alphabetical order. If you found the X first, usually you do need to find the X first, and then it will lead you on to enough information to then eventually get to the Y. So this X is within this triangle, the triangle BCD. Okay, it's in there. So we're going to use our first rule here, that angles in a triangle equal 180. So I'm going to do some annotations. It's always good to just annotate what you're talking about. So the 180, okay, take away your 35, take away your 30. Okay, so you're doing 180, taking away 65. Okay, and that leaves you with 115 degrees. So therefore, X equals 115 degrees. You can put that there to make it clear you found it. You can write it on the diagram, you can do both, but whatever you do, make sure your intentions are very clear. Okay, so we've done that first one. Now we're going to use the fact that the angles on a straight line add up to 180. So because we've got a missing angle here now, and it's like a little puzzle. These questions are just like a puzzle, but I unpick them bit by bit. So if we can find this angle here, then we can go on to find what Y is. Now, on the straight line, 180. So to find this angle, it's going to be 180. Take away your X value of 115. Okay, now that is going to give me 65 degrees. Okay. I'm not doing this in my head. I would never do it in my head. I'd always write it down as a calculation or use a calculator. So if you're not sure about doing subtraction as a non-calc method, please do go and find the subtraction methods on our YouTube channel. So 65 degrees here. So that means that I have got in this quadrilateral A, B, D, E, I've got 360 degrees because a quadrilateral is equal to 360 degrees and you add them up. I'm going to take away the 65 and I'm also going to take away the 95. Okay, and I am left with 200 degrees. Now that is not the answer to y, because y, the 200 degrees that's left over, is split between these two y angles, and so therefore y is going to be 100 degrees. Okay, so just to double check that, if we then have the 200 plus your 95, so a little bit of a check, you can do 200 plus your 95 plus your 65, you must get to 360 degrees. So just do a little check to make sure that it adds back up and that it does all add to 360. Okay, a little check at the end. You can do a check for every single maths question, and it just saves you from wasting all that time. It could be a tiny little error and you won't have lost all the marks. So it asks you the value of x. Make sure you put that clearly on here, and it's definitely worth finding an answer line somewhere and writing the answer on the answer line. Okay, and the reasons, they usually just accept, it would be accepted if you could see some on your page, the reasons in full, and really important are things like the actual words, you know, angles, oops, yeah. Just got rid of that now, what happened there? Okay, they would be looking for the actual specific language, okay, to do with angle rules, and in this case you can say that it's, so I'm going to do this now, yeah, angles, straight line, add up to 180 degrees, okay, angles, triangle, sum or add up to 180 degrees, angles, quadrilateral, add up to 360. You can't just say a straight line equals 180, okay, you say angles on a straight line. Right, let's move on to the next one. Okay, so here we've got a pentagon. Okay, so it's told us it's a pentagon. We can see it's got 5 sides, hopefully. They're after the angle BC. They tell you that angle BCD is twice as big as angle ABC. It looks twice as big. It's certainly not the same, is it? You can tell that. In these sorts of questions, if an angle looks the same on parallel lines, you can take it as being the same if it's on the parallel line, but you can't assume anything unless it tells you that, or unless it's on parallel lines. We're looking at this angle here, angle BCD, so it's worth just noting on the page which is angle BCD. So angle, it's often written like this as well, BCD, you want the angle at the point that's in the middle of that reference, in the middle there. So we're looking for this angle here. That's the one we're trying to find for our final answer. Okay, be very clear what you're trying to find. Okay, back to the pentagon thing. So angles in a triangle. Okay, in a triangle, add up to 180. We've just said that angles in a quadrilateral, so that's any 4-sided shape, okay, equal 360. Now you might see a pattern here. From here to here, you're adding on 360. So let's add on another side. So angles in a pentagon, 5-sided shape. Okay, we're going to add on 180, and that would take us to 540. Now you can just, people do sometimes just learn these numbers as they go up, and as you go up, you add 180. But there are a couple of ways you can find that if you don't know that. And here's my favourite way of doing this. I go from one corner and I have to draw, see how many triangles I can draw from that corner, just from that corner. And you will find that in any polygon, you can draw exactly 2 triangles less than the number of sides. So it's the number of sides, n for the number of sides, take away 2, okay, times 180. Now I'm going to put this in brackets, otherwise big maths will get us in trouble here. So it's the number of sides take away 2. So here 5 take away 2 times 180. Because I've got one triangle here, I've got one triangle here, I've got one triangle here. So I've got 3 triangles in total. Okay, just label this 1, 2, 3 instead actually. So I've actually got 3 triangles that I can draw from one point in my shape here, my pentagon. 1, 2, 3. And that's because we're looking at the angles in those triangles. There's an angle in the triangle, there's one, there's one. That lot equals 180. And then this is the next triangle here. 1, that little bit there, and that little bit there. Okay, those green bits add up to 180 because it's a triangle. And then that little bit there, that little bit there, and that little bit there add up to 180 in your triangle. And then if you look, you've then got actually this angle here, okay, plus this angle here, plus this angle here. So these are all these triangles, these 3 triangles, okay, the 3 triangles in your pentagon. Those 3 triangles, all those corner angles of the triangles will add up to the 3 lots of 180. So they will add up to 540 degrees. That's just one way of finding it out. There is another way to do with exterior and interior angles. I think that's more complicated. It needs to be used sometimes when you don't know how many, you don't know how many sides you've got. You have to use that sometimes. But this is a nice way to just split your shape up. How many triangles? That number of triangles. So 3 times 180. Okay, gets you the sum of the angles inside. Okay, so don't forget it's the sum of the angles. If you then needed to find one angle in a regular shape, you'd have to divide by the 5 angles that are in there. But this is not a regular shape, it's irregular. You can see that because the sides are different, the angles are different. So we've got our 540 total. You either have to work it out or you have to pick it out from a list that you might be able to remember, or adding on 180 for every extra side you add to your shape, starting with the triangle that you just need to know that triangle one. Okay, so we're trying to find this angle down here. We've got a missing angle here. So the first step is to use our total. Let's use our total of 540. Oops. This pen's not playing very well today. Okay, 540. Take away the 125. Take away the 115. And don't forget also to take away that 90 degrees down in the corner here. Don't forget that is 90 degrees. You don't get any points for labeling it, but it's worth doing so you don't forget it. Okay, 90 degrees. Okay, so we end up with a total of 210. My pen working again? Something's gone wrong here. It's just gone to sleep. Right. Bear with me, sorry about this. Right, hopefully, here we go. Yes, right, equals 210. So you've got a balance of 210 to split between this angle here and that angle down here. They're the ones we don't know about yet. But it does say down here that angle BCD is twice as big as angle ABC, and you can see that. So this is about ratio, or about thinking, right, you're going to have, you could do it as boxes, you could do it as ratio. So imagine you've got those 2 angles total together. This first one, okay, is twice as big as this one. So we could draw it into 3 boxes and think about the whole total 210 has to be split equally between those 3 boxes, which is just like doing ratio. Okay, ratio of 2 to 1, it's twice as big as this one. Okay, so this is BCD. And this is ABC. It's twice as big as ABC. So you can use your ratio spider with your 210 in. You've got 2 parts for one angle, you've got 1 part for the other. This, you can use the adding up method, add, divide and multiply. And basically you've got your 210, you can use your boxes method. Here we go again. You can use your boxes method. Or the ratio method, Adam, or the spider. You're basically got that 210 degrees. You're sharing it by 3, which gives you 70 degrees. That means that each part is 70 degrees. So each part of this ratio is 70 degrees. Each box is 70 degrees in the boxes there. However you want to do it, that's 70 degrees. Okay, there's various ways of splitting out a ratio, and this part here is the bigger angle and this part here is the smaller angle. Okay, so that means that the angle BCD must be equal to 140 degrees because it is 2 lots of 70, 2 times 70, 140 degrees. Okay. Right, this one is quite interesting. So this one, angles in a triangle are a ratio 1 to 2 to 3. So this might just frighten people thinking, crikey, a ratio in triangles, that's not fair. Neil says this is a right angle triangle. Is he correct? Show with reasoning. So 1 to 2 to 3. Again, you could use a spider, you could use boxes, you could use the adding method. Basically, ratio is about adding the parts, okay, and then dividing. So let's add these parts. That's 6 parts. Sorry, 6 parts. Or in your spider, it's 6 legs. Okay. The spider, you've got 1 part here, the smallest angle, the medium-sized angle, and the biggest angle. 3 parts. It's equally split. So a triangle, we know, is 180 degrees. So we're sharing out 180 degrees amongst those 6 legs equally. These 6 parts are 180. Okay, divide by 6. This could easily be non-calculator. Bus stop idea of 6's into 180. Okay, 6 into 180. So 6's into 1 don't go. 6's into 18. Go 3. And then the 0. So that means each part is worth 30 degrees. So on our spider, we can write 30 on each leg. Okay, 30, and so on. And it also means if we wrote it as the ratio, 1 to 2 to 3, 1 to 2 to 3. It means this smallest angle must be 30. Okay, this one is twice as big, it's 2 parts, so it must be 60. And this last part, the last angle, is 3 parts, so 3 times 30, so it's 90. So your angles are split. They can be split in a 1 to 2 to 3 ratio. And look, you've got an angle of 90 degrees, which makes it a right angle triangle. So yes, okay. He is correct. You'd also need to make a comment there about your angles in a triangle. Okay, angles in a triangle equal 180 because that's your angle reasoning in triangle. Sum or add up to 180 degrees, and then all that working out will show that it works. Okay. Okay, so another angles in triangle question here. So with these sorts of questions, when you have got this shape, you can split it into 2 separate triangles. Might be something you want to do to start with is to draw those two triangles separately, just a sketch. It just needs to be a sketch, okay? And that just helps you focus on what the finer details of the question and not get a bit muddled with it all being in one place. It's just a quick sketch so you can see what's going on. If you're okay with it on the same diagram, then that's fine. So you've got 90 degrees in the corner. There's no marks for writing 90 degrees, but they've given you that as an indicator here with the corner part marking. 22 here, and our question actually says we must give reasons for each stage. So this is what I mentioned before. If we write down our reasons at the start with, so the first reason we've got we can use is that angles, okay, in a triangle, okay, in a triangle, sum or add up to. It's a really precise words here. You must have the angle and the triangle bit there, and sum or add up to 180 degrees. So that's written down as a reason already that we can use, and they'll pick up and say, oh, you know what you're talking about, you know the rules. Second thing here, we've got on this little triangle, the top section of the big one, we've got these two markers. Now, it will nearly always tell you in the text of the question the same information. But it's worth noting that sometimes they might not put it on there in the text. So AP and AQ are equal. That's what these markers mean. And that means that these two angles are also equal. We've got ourselves an isosceles triangle here. So that's our second fact we can use. Isosceles triangle. There's no marks for the spelling, but it's worth knowing how to spell that. I sat on Swanage Cliff eating lovely egg sandwiches. Okay. Isosceles base angles are always equal. So the base angles are always the ones that are at the end of the equal lines here, okay? Angles, okay, are equal to each other. So there's our two facts we're going to use already. If we get the right working out, we'll have ticked off the reasons and not forgotten to put that at the end. That's a missed mark if you don't put these reasons down. Okay, so the first job, we're going to use this first fact of angles of 180 to find out the angle at A. So angle at A is going to be 180. Take away the 90. Now straight away you've got 90 left there, so make your calculations. If it's non-calculator paper, you might want to do that first of all and just think we've got 90 degrees left. It makes the last bit easier to do perhaps. And we're going to take away the 22. Now if it's non-calculator, you need a non-calculator method. Let's just do this quickly here. So 0 take away 2 you can't do, so you need to go and steal from the next door number. Okay, leave that as an 8. So 1, so 10 take away 2 is 8. 8 take away 2 is 6. So that angle at A is 68 degrees, and I'm going to write that on there really clearly so they can see that I know that angle is 68. Okay, I'll also write it here, and it's actually the way you'd write it is angle PAQ. You can write angle at A. It's always the one where the middle letter is the bit you're actually talking about. Okay, so we've got 68 there. So then this big triangle, we've got 68 up here then. Okay, so this little triangle is also 180 degrees in total. It's also 180 degrees. Always, every single triangle is 180. So to find these little angles here that are equal, we need to find out our balance. What have we got left to work with? So let's have 180 again. Subtract that 68, that angle at the top corner in A, and we get 112. Okay, so we've now got 112 left as a balance to share out between the angle at Q and the angle at P. So we need to do 112 divided by 2. Quick bit of bus stop demonstration here as well, because it's highly likely could be non-calculator. Choosing to 1 doesn't go. Haven't used the ones, we're going to carry that 1 over there. Choosing to 11, go 5. We've got 1 left over. 2 times 12 goes 6. So that means each angle at P and Q is 56. Work out the size of the angle at AQP. Just lost my pen again. At AQP, there you go. The angle at AQP. So what is that angle here? This angle is 56. So is this one. Quick check. You should be checking that all 3 angles do equal 180. There's a quick check for you to do. And let's just do that now. So 68 plus the 112. You've just split the 112, haven't you? 112 should add back up to being your, let's carry 10, 180. Be very careful. You put the right number in the right place. And your final answer, therefore, is angle AQP equals 56 degrees. Okay, on to the next one. Come up to Okay, so once again, we have an isosceles triangle. Okay. When angle A is 70, there are 3 possible sizes of angle B. Now, this is a bit strange, so they've not even drawn a triangle for us. So the first thing I would recommend you do is sketch. Again, it doesn't have to be anything fancy. It's your markings and your labelings that will count here. So 3 triangles I'm going to draw. Top tip, they don't give you a drawing, and you usually need one for this sort of question. Do your own drawing. So they're absolutely not to scale, okay? But equilateral to me. So I'm going to label them A, B, C, and you could, I suppose, turn your triangles. I want to just have my triangles all around the right way, and I'm going to change where the isosceles equal sides are each time, just because that's the way my brain likes to work. So 3 identical triangles here at the moment. Now we're going to change it. We're going to have 2 equal sides there on that first triangle. The 2 equal sides are there on that triangle. And the remaining one, the 2 equal sides are there. Okay, so it says that angle A is 70. We absolutely know, they just told us. So 70 up here. Okay, we've got 70 here. Oops. Got 70 there. What's going on? Just lost my triangle. Put the line back in. Okay, we've got 70 here, because it tells me that I'm 70 every time on my A angle. Okay, so these 2 are equal sides, so therefore these 2 base angles are equal. You've got 180 here, take away the 70, gives you 110. 110 to split between angle at C and the angle at corner B. So that's divide by 2, leaves you with 55 degrees. So the first option is 55 degrees, okay, for B. Here, 70 here. Now, these are now our two equal lengths, so therefore this angle here and this angle here have to be the equal base angles. Now, notice it's not on the base because it's turned around, but imagine turning your page around. These are the base angles. So therefore, this angle at B also must be 70 because it's equal to that one there. So that's a nice straightforward one, 70 degrees. And this final one, we've got 70 up here. So if that one's 70, these are our isosceles equal side markers. So the base angles are now at the end of those lines. So this one here must be 70. So what's that leave for angle B then? So angle B is going to be 180. Take away 2 lots of 70, which is 140. So you're left with 40 degrees, and that 40 degrees must be the angle at B. Again, just a quick check that all 3 angles in all 3 triangles equals 180, and that your base angles each time are equal. So those two are equal, those two are equal, and these two are equal at 55 each. So that's it. Okay. Now the last part of this is saying if there's an angle of A is 120, there's only one possible size of angle B. So let's just sketch that one out as well, another triangle. So our third triangle here. Okay. It's now a bit more to scale because 120 is bigger than 90, is almost there. 120 here at A. If they're saying that is 120. Now, this cannot be a base angle, okay? Because if you had two of them, it would be 240, and therefore that does not work for the angles in the triangle. So it must be that these two are our equal sides and these two are our equal angles, and B and C. So when it's 120, there's only one possible option, and we've got 60 degrees left to use. 180 minus 120 is 60. So therefore, the angle at B, divide that by 2, it must be 30. Now it says give your reason, so it's going to be 30 degrees, but why is that? And the reason is, as I just said at the beginning, A cannot be a base angle. Cannot be one of the equal base angles because it would be over the 180 base angle. 2 times 120, we could say, is equal to 240. 240 more than, okay, more than, okay, so that's more than the 180 allowed. Okay, in a triangle, the more you can put down, the more likely you are that you've said enough. More than 180 degrees allowed in a triangle. Okay, that should just about do it. So another question here with angles on parallel lines. So we need to be thinking here, we're trying to find out, what is it we're trying to find out? We are trying to find out or show that angle ABF is 70 degrees. So ABF is this angle here in this corner, okay, in this vertex. So we need to use all our knowledge of angles on parallel lines. And as always, it says give a reason. Okay, give a reason for your each stage of your working. So first thing we need to look at is what we can grab from this diagram. Now it's a parallelogram, so previously we've had the rule that opposite angles in a parallelogram are equal. So there's our first give. We can take that from there and that from there. And we've also got a really nice little gift here. This angle here is, they're on parallel lines with one across the same transversal. So these two angles here are equal. So our two reasons we need to write down for this, that will get us our mark for the reasoning. Firstly, opposite angles. Okay, opposite angles on a parallelogram, or in a parallelogram. I'm going to put in P because my pen's dodgy. In P, in the parallelogram, okay, are equal. That's those two blue angles are equal. And the other rule we're going to use, we're going to pick up our reasoning mark, is that these two angles here, this 35 and this one here, they are called vertically opposite angles. Vertically. Now you have to put vertically opposite, even though they're obviously not quite vertical. You have to use that terminology. Opposite angles, and let's not have any angels spelled differently. Angles, okay, are equal. So those are our two reasons. And there's also another one going to come into play here as well. And that is in the end, we've got the angle ABF. This creates a triangle here. So we're going to say that, use our triangle rule, okay, angles in a triangle. Now you won't use the word, just trying to save space here, angles in a triangle, okay, sum to or add up to 180. So if you've got all those three reasons, look at your shape and think, what can I pick out? What can I use? And there's your three reasons. There's your final mark if you've got the numbers right. Okay, so let's go for it. So this angle here is 35. We can write it in. That's 35 there. And now, because of this blue angle over here, it's being opposite in the parallelogram. You know it's parallelogram, but you've got this side here and this side here equal. Okay, and you've got this marker here and this marker here. And they've actually told you as well. So we didn't spot that. They've actually told you ABCD is a parallelogram. Okay, so we can now write that 75 over here. Now it's in parallel lines, it's in a parallelogram. If they look the same, they are the same. So those are the two acute angles here. These two, the one at D and the one at the vertex on B, are the two obtuse angles. So just a little reminder there actually. This one is acute. Okay, and this one over here, this big one here, okay, is obtuse. Now this is just one way of solving it. I think I've spotted this. This is the easiest way to solve it. There will be other ways of solving the same question, but this is the most straightforward way of doing this. So, and I would always label that. See, that is going to be, that rule goes with that there, okay? And that this rule is going to go with this angle here. So you're sort of labeling what rule goes with what part, just to be safe. So we've got our triangle here now, which should be 180. So 180. Okay, subtract that 75 and that 35. Okay, so that's taking away 110 in total, leaves us with 70 degrees. So we've just shown what they wanted us to show. This is 70 degrees. You've shown it by calculation, you've given your reasons, and yes, it is 70 degrees. Okay, job done. Okay, it's just one more on these parallel, to do parallel lines and polygons. So, okay, show that x is equal to 30 degrees. So we've got, again, we're not many options on this one actually. So we are going to use the fact that this is a straight line. Okay, here is a straight line. So at P, this must also be 90. So if that's 90, we could then find out this angle here. Okay, and so we've got 180. And again, this is your angles in triangles. So triangles going to be really lazy here. You wouldn't do this in the exam. Okay, triangle angles, angles in a triangle, sum to 180 degrees. Okay, 180 degrees. So 180, take away your 90, take away 105. Okay, you are left with 75 degrees. So 75 degrees down here. Right, so we have now got various options we can do. So we could assume this, we could take that 30 they've given us actually. If we took that 30 there now, they've given us. If that is 30, all right, so we're using the if it's 30, we're assuming it's 30 and we're going to prove it backwards. If that's 30, then this angle in the corner here, okay, is going to equal, what's that, 105 in the corner here, let's see. And it means that these two red angles here must equal 180 because they would end up being co-interior angles, okay, on this parallelogram here. They're co-interior on parallel lines. So they're co-interior. So that's one route we could take, by taking their 30 and working backwards with it. But actually, we've actually also got another way here, which gets us towards the 30, going forwards rather than going backwards. So here, if you look, we have got, if you can see this, just change the pen size. We have got, going from the X, we've got this line here, okay? If we draw it down there like that, okay? Hopefully you can see, if you were to turn your head around here, you can see a Z angle. Now, we're not allowed to call them Z angles anymore. So a Z angle, think about A to Z in the alphabet. A goes with Z. So it's an alternate angle. Okay, alternate angle. And alternate angles, okay, are equal. They're equal to each other. Right, so that means this angle here, this 30, okay, that they've given us, has got to also equal this here. So we're not really going from nothing to the 30, we're coming from the 30 still. So you've got 30 here. Okay, you've got 90 here. Again, no marks for writing 90. And that means 90, 30, that's going to be, we've got to do 180 here. Take away 90 and take away 30. Okay, and take away 30. That's taking 120, so we've got 60 left, 60 degrees. So that gives us this angle down here as 60 degrees. Okay, which gives this angle here as 75 degrees. The whole corner is 75. So this corner here is 75. Okay, and this corner here, if we assume that 30, that is 105. If you add these two together, they do equal 180 degrees. So we are using, first of all, the angle of the triangle to find this missing one here. If we then use that 30, we can do it either by looking at this and saying, well, that's 105, take off our 15, what's left? We get 60, or slide this angle up here because it's equal, finding out that gap, and that is 60 that way, and then adding them up, and we must equal 180 on the co-interior. Okay, so a couple of different ways to approach it, but we do need to use that 30, put it in, plug it in to show that it all works out and it all adds up to get that to be 30. Okay, good luck. Okay, so one more question for angles inside polygons. Now this one here, it does tell you that it is a parallelogram. So what you need to do is use that information to label this diagram up. So if it's parallelogram, means this angle, this line here is parallel to this line here. And it means that this line here is parallel to this line here. So it's worth noting that on, because then you might be able to use your line angles in parallel rules. There are some other rules you can use here as well. So, and the fact that it is a parallelogram, parallelograms have special properties. Two properties we can note. The angles in a parallelogram, I'm not going to write the whole word, equal 360 because it is a quadrilateral. Okay, and the second fact we can use is that opposite angles in a parallelogram, okay, opposite angles in a parallelogram are equal. So that's going to help us out here an awful lot to solve this. Okay. So, and we've also got the, we've got a hidden triangle in there. So A to P to D, there's a triangle in there. So we're going to use that triangle in a minute as well. So we've also got our angles in a triangle. Now you'd always write the words here. I'm just doing this to have some space. and you'd write add up to 180. So we're going to use that fact as well. So all our reasons listed to start with. So we've got those ready, and if you forget to write down the reasons at the end, we've got them there and we pick up those extra marks. Okay, so that last one here, opposite angles in parallelogram, that means that this angle here, this 130, must be the same as this big angle over here, the opposite corner. Okay, now these are parallel lines, so this top parallel line, bottom parallel line, and these parallels. So I said before that if angles on parallel lines look the same, you can take it that they are the same, they're on parallels. So this one here opposite this one here, okay, because it's just been a squashed rectangle, the opposite, they're equal. It also means that this angle here, okay, is equal to the whole angle in the corner here. So two key bits of information there. Opposite angles in a parallelogram are equal. You could also use the fact that this angle here, because you've got parallel lines and one transversal crossing it, this A to B line is crossing. If I just extend this here, you're used to seeing parallel line questions like this. So always think, well, can I do anything else to my diagram that helps me out? So this angle at the top here, this 130, okay, plus this angle in the corner, this might help you. You might find a different way into it. These two angles here, okay, are co-interior. So even if you don't use this, it's a good bit of revision here. Co-interior angles, okay, equal 180. They don't equal each other, they equal 180 degrees. So these two corners will equal 180 degrees. So straight away, you could start with that method. Actually, I started a different way when I did it earlier, but I'm gonna start a different way first to find x. So there's actually another way of attacking this problem. There's usually more than one way to attack any of these angle type questions. Okay, so let's just try and find x first of all. So we've got this triangle, and inside this triangle is 180 degrees. So if we take off that 135, which has already been used up, okay, take away the 135 degrees, okay, we are going to have 45 degrees left over. Okay, now be very careful, we've not found x here, so you label everything, we've just found that angle there, 45 degrees. Okay, again, use a calculator or show a method. I'm just doing this for speed. I've got these notes already prepared, but get yourself a decent subtraction method or use a calculator if you're allowed to. Look at the YouTube for the non-calculator method of subtraction if you're not sure about it. So in this corner here, this blue angle is 130. We've already used up 45 of it. So for this corner angle here, and annotating away to make it really clear so the person marking can see. This is 130, this corner angle. So if I take away the 45 that I've just found, okay, I get an angle of 85 degrees. Now, this is where that little label that says not drawn accurately is definitely worth noting, because these two angles here, okay, they don't look very different to me, but by calculation, this one is 45, and by calculation, this one is 85. So don't be thrown, make sure you look at this very, take that into account. It's not drawn accurately, so they're not going to look accurate angles. This is 85 here, and if I add these two together, they must equal 130. They do, 80, 120, 130. A little check as I go along. So we found x. I'm just going to label that is equal to x. Okay, so now I want to try and find y. Now we've got two ways of doing this. We could think about the whole parallelogram. The whole parallelogram is 360. So the whole parallelogram is 360. And then we could take off the 260 that we have used up on the other corners where x and the opposite corner is. It means we've got 100 degrees left to split out between this corner and the one down at the other side. Okay, so it's that one, and it's going to also come down. How can I do this without making too much of a mess? and this corner down here, the whole corner. So we need to divide that by 2. So we'll have 50 degrees here, sorry, 50 degrees here, and this corner is 50 degrees. And so if we take off that 35 that's already been used up, okay, we get an angle here of 15 degrees. So labeling everything, so y equals 15 degrees. Okay. Now let's go to this co-interior method instead, because some of you might think, oh, well, I could use that method instead. So the co-interior, we've got 130 here, and these two added together must be 180. So therefore 130 take away your 180 take away your 130 leaves you with 50 degrees for that corner, and that's when you can then again do your 50, take away the 30 that's already there, 35 that's already there, you get 15 degrees. So just a slightly different variation at the end there for finding that Y angle. There you go. So that's a few questions on using angles on parallels or angles in polygons, and it's just definitely you need to note down what the rules are, okay, and you also need to draw things out, okay, you need to label as you go, okay, learn the techniques for finding total angles in a shape, okay, and very clearly label your answers at the end. Okay, good luck.